What's up, my chemistry people? It's Mr. Boylan in the house. Today, we are going to use thermochemical equations to calculate energy changes that occur in chemical reactions and classify reactions as exothermic or endothermic. Now, that may seem pretty similar to what we did in the last video, so let's break it down a little bit, see what we're going to do differently in this one. If we break that down, we're going to focus today on Hess's Law to calculate the enthalpy change or the heat of a reaction. Our notes are pretty short and pretty sweet today. First of all, Hess's Law is just a law that states that the overall enthalpy change in a reaction is equal to the sum of all the reactions for the process and is independent of the route taken. In other words, we say it's a state function. Basically, just a couple of things that we can use for Hess's Law. One, if you reverse the reaction, then you change the sign of the enthalpy change. For example, as you look at the equation we have here in the forward direction, we've got an enthalpy change of positive 60 kilojoules. If we were to reverse that reaction, we would get an enthalpy change of negative 60 kilojoules. Rule number 2 for Hess's Law, if you end up multiplying the reaction by a coefficient, you must multiply the value for the enthalpy change by the same coefficient. For example, your general equation A plus B forms C will give you an enthalpy change of 60 kilojoules. If you were to multiply that reaction by a coefficient of 2, you'd have to double your enthalpy change by 2 as well. And then lastly, keep in mind you can combine those two first rules. So if you were to say reverse and then multiply an equation, you must change the sign and then multiply that equation by whatever coefficient used, in this case 3. And that in a nutshell sums up Hess's Law and what you need to know for today's class.